Welcome to the Stormwater Management Introduction video. Today, I'm going to explore the many different types of stormwater management, starting with different types of basin designs and then moving into some contemporary innovations that have been implemented based on different design constraints. I'd like to first start off by explaining what stormwater management is and why it's important. Stormwater management is the control of flooding through the routing of runoff, or the stormwater that is accumulated and discharged due to impervious land coverage, into different systems that control what the runoff does. Stormwater management is important because it helps to reduce erosion, improve water quality, and keep safe conditions in a developed area. The first system I'd like to talk about are detention basins, or dry basins, which are the most common type of stormwater management solution. They are large, man-made depressions in the ground that are often located on the sides of parking lots or large buildings. These basins are dry except for after a storm event where they pool water for up to 3 days while the water is safely drained out. As seen in this diagram, detention basins usually have a sloped grass perimeter with one or more inlet structures that deliver runoff into the basin. These inlets are often surrounded by rocks to help prevent erosion by slowing the water down when it enters the basin. The water then pools in the basin and slowly drains out through an outlet structure that has a small orifice for normal events and a large orifice for extreme events, as well as infiltrating into the bottom of the basin. Next on the list are retention ponds, or wet ponds. These have components similar to dry basins, but are designed to hold a permanent volume of water, usually sourced from the groundwater table. A retention pond can improve water quality and recharge the groundwater table while being aesthetically pleasing, especially when coupled with water features and vegetation around it. Wet ponds are most frequently used to improve water quality by mimicking a small natural pond. Biological actions can help clean water through the use of aquatic plants and animals to help break down bacteria because of the longer holding time between rainfall events. These wet ponds also have inlet and outlet structures but require frequent maintenance and inspection. If a retention basin collects debris or possesses stagnant water, mosquitoes and other pests may breed there and cause an unpleasant environment. Next, we have infiltration basins. Infiltration basins are similar in size and shape to both detention and retention basins, but have one difference in the way that they handle the stormwater. There are no outlet structures inside the infiltration basins, so where does all the stormwater go? Instead of slowly flowing out into a water source, these infiltration basins are lined with highly permeable soils that can effectively soak up water and reduce peak flows from a storm event. Pollutants in runoff are treated through the processes of filtration through the biological and chemical activity within the soil. Infiltration basins are common in smaller development areas due to their water drainage being slower than that of a basin using an orifice for outflow. Next, I'd like to introduce some of the less popular solutions that may only be necessary for some extreme cases, starting with underground storage. Underground storage is the compounding of stormwater in large underground chambers below a project site, usually the parking lot. The chambers can be made of PVC pipes or concrete vaults. These chambers would act as a regular detention basin, temporarily holding stormwater and releasing it at a controlled rate into the groundwater table. Underground storage is a frequently used solution when there is not enough land to dig out an entire stormwater basin, such as in urban areas. Lastly, permeable or porous pavement is a growing stormwater management solution due to its simple maintenance and aesthetically pleasing design. Permeable pavement can be applied in a variety of different designs, such as asphalt concrete or interlocking pavers. The pavement has little to no sand and small openings in between the aggregates or pavers depending on the type of pavement to allow water to pass through during a storm event. Under the primary layer is a bedding of aggregate with base and sub-base layers below the beddings. In these layers, the aggregates become coarser as depth increases, acting as a small detention area to store and filter water. While the water is being stored under the pavement, it will slowly infiltrate into the soil. There is also an overflow pipe within the subbase in the case of an extreme rainfall event. This stormwater management system will eliminate runoff completely, resulting in recharging of the groundwater table and reduction in temperature across the project site.